So a replacement reaction always produces a compound and an element whenever it's a normal replacement. Then your basic equation is AX plus B, and A has a positive charge, B has a negative charge, and this B right here has a 0 right now, but if you look it up on your pink sheet, you will find that it has a positive charge on there. So when you replace positives, BX plus A. When you get through, you have a plus charge with a minus charge, and then you have the A has a 0 charge now because it's in a space by itself. All right? The other possibility is that I have something like AX plus Y. Remember, the first of the alphabet represents metals. They have a positive charge. The last part of the alphabet represents nonmetals. They have a negative charge. So if I look at this, I have a plus and a minus. This is a 0 right now, but if I look it up on my pink sheet, it has a negative charge. So since negatives replace negatives, I'm going to have AY plus X. So the Y is going to kick the X out. Plus 1, plus, and a minus, and then that has a 0 charge once it gets kicked out. It's in a space by itself. All right, so this is a single replacement basic reaction. You have two exceptions. One of the exceptions is very active metals. Very active metals with water. Now the very active metals are the ones in the first two columns. The ones in the first two columns. Now to help you remember and identify them, we're going to take out your pink sheet and we're going to write VA by those elements. So we'll be on page 1. This is to help you remember that these are very active. Now we watched videos of these very active metals reacting with water. You remember first semester. And some of them were explosive. What?
What did you say right after very
I'm going to fix it up. VA. Very active. All right, so the first one is lithium, sodium, potassium, rubidium, cesium, and then we're going to add Fr plus 1 is also 1. F francium plus 1 is also 1. It's not on your list. Every element in the first column has a plus 1 charge. All right, the next one is Be, beryllium, Mg, magnesium, Ca, calcium, Sr, strontium, Ra, radium, and let's say Ba, barium, and then one that's not on there is radium, Ra. It's a plus 2 charge. Okay, so it's a plus 2 charge. Now, do you have to sit down and memorize those? No. You need to know that they come from the first two columns on your periodic table, and you always have your periodic table available. So whenever you take a test, you're not going to have yours, you're going to have mine that has the stuff written on it. So that's just a reminder. All right, so here is the situation when you have a very active metal plus water. So you have to have water and it has to be very active. You're going to produce VaOH plus H2. That's your product. You kick one of the hydrogens out. Now I explain it like this, or I give you a visual like this. Very active metals are very hyper. So when they run in and they see a water molecule like we have here, here's 2 hydrogens and an oxygen, water molecule, well they come in so fast they knock one of the hydrogens out of the way and bond to what's left over because they are so active. Just come in there and kick you out of the way to do. Alright? Now, not very active metals, those that are in the middle of the periodic table, they're kind of laid back, you know, I'm going to take my time. So the not so active metals come in and kick both of the hydrogens out and bond and make an oxide with the oxygen. Okay? So you got to identify very active metals as opposed to not very active metals. So when we look at this, we have something like Na plus H2O. Determine what type of reaction it is first. It's a single replacement or displacement. And then it's got water. Well, that's a cue for me to think, is that sodium, does it come from the very active metal? So I'd look at the periodic table and say yes, comes from the very active metals. So my product is going to be NaOH plus H2. You are predicting those products. Now you have to balance. The sodiums are balanced. The O's are balanced. You have to skip the H's because they're in too many places to save those for last. Then the H's, I have 2, and over here I have 2 plus 1, 3. So odd even says go back and double the first thing you did. And when you get through doubling that, that's what you're going to get to make it balance. This used to be one of the hardest equations to balance until I figured out one day something about that odd even thing. It just made things clearer for the students and it makes it easier for you. All right, so odd even, you have to look at very active metal and I have water. All right, now suppose I have Fe plus H2O. What are my products? I'm going to have OH. Why would I have an OH? Is Fe one of those very active metals? No. From here I'd have to say Fe is going to be a plus 3, for example, or plus 2, whichever one I want it to be. So is Fe a very active metal? No, it's going to saunter in, lay back, kick both hydrogens out of the house, and bond with the oxygen. Okay? So we're going to have FeO, Fe2O3, right, plus H2, because all the hydrogens are kicked out and they have to form H2. All right? And then, of course, you balance 2, 3, 3, that balance. Okay? So that's one exception. Now, the other exception, you don't even get a compound and an element. When you have a combustion reaction and you have a CH plus oxygen reactants, you're going to produce the same products every time. You're going to produce CO2 and H2O every time. Now, on your keep it forever place, write down combustion equals burning. So when I say combustion, I mean burning. If I say burning, it's a combustion. And it always requires oxygen. It requires oxygen. Things burn in oxygen. Got the oxygen part of it? Add it to it if it's not there. It requires oxygen. It requires oxygen. Do what? Okay. All right. So, in this situation, I'm going to get the example of C6H6 H6 plus O2 yields. When I see oxygen, the first thing I think is combustion. And I look to see if the other thing that's on the reactant side is a CH compound. It might even be a CHO compound, but it still has the C and the H in it. So is it a CH compound? Yes. So I don't have to even think. The products are going to be CO2 and H2O. So CO2 and H2O. I had a student a few years ago that said, I remember that by saying co-host. That's fine. That's a good way to remember. C-O-H-O. Co-host. That's what she came up with, and it worked for her. It might work for you. Yep, could be. All right, so co-host, I know what the products are. All I have to do is balance. And to balance this, it's going to be something like this. All right, so that balances that. Okay? I'm not going through the balancing part of it unless you need me to help you with it. All right, so let's do a couple of examples. Okay, I'm primarily concerned with what the products are. I know you can balance side to side. We've done enough practice on that so far, but we always have to finish off balancing it side to side. The first one, standard type of single replacement, right? So what am I going to produce? A compound and an element. What's the element going to be? The element that's going to be over here is going to be iron? Al is the element. What's the compound? FeO. And we'll say that this Fe is going to be a +2 just to make our life a little easier. Okay? So we have a potentially positive element, and it's going to replace the positive part of that compound. Okay? We don't want to finish up and have two pluses together, or finish up and have two minuses together. So we have 2 here, and a 3 here, and a 3 here, balances it. All right? What about the next one? Typical type of single replacement? Yes, it is. What's the charge on your pink sheet for Cl? Negative. Hydrogen's a positive, and Br is a negative. What is the Cl going to kick out? The Br. So we're going to have HBr plus, I'm sorry, my bad, I wrote it down wrong, as usual. Right, I'm going to have hydrochloric acid plus Br. You certainly did. Good job. And then I balance. All right, the next one. It's a single replacement reaction. It has water in it, so I stop and think. Is calcium one of those very active metals? So I'm going to very active metal replace one hydrogen. CaOH. Ca is a +2. OH is a -1. Plus H2. So I'll have to have a 2 there now. You have to balance every space just like you did before. What's the charge of the calcium right here? 0, because it's in a space by itself. So that space equals 0. And of course this space equals 0, and I made this one equal 0, and that one's in a space by itself, so it's equal to 0. Okay. Now the next one, single replacement, has water. It's a laid back aluminum, so the aluminum goes AlO plus H2. Alright, and then you have to balance 2, 3, 3. The last one,
Is the one in the CH.
what are going to be the products? Get rid of the gum. You got gum? Yeah, what are the products?
CO2 and
Whoops. Yep, CO2 plus H2O. And I happen to know that this one is going to be
really big.
16 and it's going to be that. Okay? Remember, those kind of reactions, all bets are off. It's not going to always be a 1, 2, 3, 4, 6 possible. You know, that's your main ones you use most every time, except this one. These are weird. All right, are we good?